This is Module 7, Part 4 of the Foundations of Programming with Python video series. In this part, I want to talk about structured error handling, raising custom errors, and creating custom exception classes. We have seen that there are quite a number of built-in errors and exception classes within Python. So can we make use of the exception class to do a customized error handling for us in our code? And this is how we actually can do it. So I have added code here to raise an exception. So raising an exception means at this point we are generating an error, an exception, and ask Python to handle this with the try except blocks. So what I'm doing here is I'm limiting my input to an upper limit of 2000. So let's simply see it in action, what is happening here. So if I'm entering 10, I'm dividing by this 20 by this value, I get 2.0, I get the final found error exception as what we had previously. So all the code works the same as previously. So if I'm entering 2000, which is the upper limit, the exception is being raised the moment I'm larger than 2000 or greater than 2000. So with 2000, I'm still doing the calculation. The moment I'm entering 2001, the behavior changes. There was a general error, so I'm actually in this exception as E block because it's just an exception that I'm raising. It's not a specific error. It's a general exception that I'm raising. And here is the built-in error info. I'm getting class exception, and I'm actually getting this message that I put in here. So I'm invoking an exception in line 16. I'm invoking an exception, and I am giving that exception as an argument, this string, do not use numbers greater than 2000. And because the exception is invoked with this argument, this exception class is using this argument as the message. And I'm getting do not use numbers greater than 2000 as my exception. And then again, it's the common base class for all non-exit exceptions is the docstring, what I'm getting, which is the general one. So this way, I actually can raise custom errors and raise and create an exception, and then have the try except block to actually handle this. Now, taking this one step further, instead of actually using just the general exception class, I even can create my custom errors. And this I do with creating my custom exception class. And this in bracket exceptions here means I'm inheriting from the exception class. So all the functionality that the exception class has is being inherited into my value to low error. I'm having a docstring in here, and I'm defining the Understring class. Now you see that we're not using the add static add static method, but have a self in here. For now, just go with this. We're going to be looking at that in the next module what all the different types of classes or what those keywords mean for classes and what the mechanics behind there are. We're creating an Understring method to actually return this error message. Now, in my code, in my try block, I'm actually checking that if int value is larger than or greater than 2000, then I'm raising a value to high arrow. If it is lesser than 0, I'm raising a value to low arrow. So let's see what is happening here if we're running this. Actually, I first need to exit the old one. Then I can fire you up. So if I'm within the values, it works as expected. If I'm doing a 0, I'm getting a division by 0 error, because this only kicks in if it's less than 0. So if I'm giving a -10, I'm actually getting value entered is below allowed lower limit, which is our Understring. Value entered is below allowed lower limit. And then the dog that I'm pulling out here is value exceeds lower bound. This is actually here my dog string that is being pulled here. Same if I'm entering something that is greater than the upper limit, so I'm getting the custom error messages here as well and the custom functionality. So you can add quite a number of those exception classes to your code and work with those to really create a robust application and introduce a lot of customized error handling and error behavior. Typically, try to stick with as much as possible with the already built-in ones. There is reasons to go with custom exception classes. Most cases you will not need this, but we will see examples for either one. With this, we are coming to the lab 7C, which is a lab about the structured error handling. In this lab, we'll continue with our code from the last lab, 7B. And what I want you to do there is that you add error handling whenever there is an I/O interaction. Don't create your own classes, just use what Python has already built in there. You have seen the inconversion error and the file not found error. So add code for catching errors around the file operations, that is 2 areas, and then add code to catch errors around the user input operations. And there handle the non-numeric inputs, and value 0 input for the number used is denominator separately. So create a little bit of custom handling like we have been seeing in your code. Then test your script and write down how your code works. Now, one comment about testing is test in a way to actually make sure that your script or your code works with good values. But the real testing actually happens by trying to break how your code works. So trying invalid values, all kinds of invalid values that you can be thinking of, or all kinds of classes of invalid values that you can think of. Try to break and poke holes into how your system is working, and try to do that in some form of a systematical way. So if we are trying to do a zero division error handling, make sure that you're trying the zero. Try the zero in both of the values. Stuff like that. Try to do it systematically. And make sure that as your code is behaving correctly in the exact error condition and not in anything else. So this way you're kind of in a negative approach. You're trying to break your code. You're using what you know must generate an error, and then make sure, first of all, it is generating the error, and second of all, it is handling the error correctly. And so trying to break your code in this way tells you more about, or verifies more that your code is working correctly than just using good values and good examples. After this lab, I want to mention something. You don't need to do a lot with that. I want to mention this because we kind of have been looking at this in our GitHub repositories in the readme.md file. So this readme file on GitHub is using its own language to actually format the text in that readme file. Perhaps I should simply go into GitHub and see if I'm still logged in. Yes, I'm still in. So I'm simply going into an old assignment, and here we have the readme file. Now if you go on this pen to actually edit this file, then you see that there is this number symbol in the front here. And what this is, it is part of what is called the markup language. The markup language is a simplified way of quick formatting documents for the web. The markup language is being utilized by the server in the background when it's actually rendering the page to HTML code to show on the client, so in your browser. So the work is done in this case by the GitHub server. And what this is showing, this is, I'm going to tell you, it's an header of level 1. I'm also going to be and this is the documentation of the GitHub flavored Markdown. Sometimes it's markup, sometimes it's Markdown. It's the same spec. And just scrolling through here, it actually tells you what it is, where it is coming from, and then a portion of formatting that you actually can do. So just scrolling down here, I'm looking for you have examples for tabs. I'm looking for the blocks and inlines, and you can actually create different blocks or different appearance of your text this way. So if you have been working with HTML before, then you know what HTML is doing. This is how it is simplified in this Markdown language. And here are actually our headings. So this is our level 1 heading, and we can add additional headings. So I'm just going to be doing this. So by using 2, that is our heading 2. Now if I'm committing the changes and actually seeing this README page, you see it has changed, and it's a different size of the character, a different point size of the font. Also, this is a little bit heavier than this, so it's being rendered a little bit different on the page, and this is what the Markdown language is. Now, I wanted to tell you this, that if you like, you can customize your welcome message here on the readme.md file a little bit in your repository. It is not required for this course, but it is good to know, to have heard about it, because the moment you're out in the field, you're probably going to be customizing these pages quite a bit. So having heard about the Markdown language and what it is, having a reference to where to look is going to be helpful for you. So if you like, use this to actually customize the assignment repository that we're going to be creating for this module's assignment, and start creating a little bit of customized welcome message here in the README file, and add a little bit text to it for your colleague students who are going to be actually having a look at your code. With that, I'm concluding part 4 of Module 7 of the Foundations of Programming with Python video series, and I'll see you in a moment in the summary.